All right, today we're diving into a nanotechnology breakthrough, and this one is tackling one of the oldest, most expensive problems in all of physics. I mean, just imagine a world where our machines run smoother, last way longer, and use a fraction of the energy. Sounds a bit like sci-fi, right? Well, the key might just be a tiny material that's shaped, believe it or not, like something you'd find in your kitchen. Okay, so first things first, let's talk about the villain of this story, friction. It's this constant, invisible force that affects, well, pretty much everything that moves. You know, from the engine in your car all the way up to massive factory gearboxes, friction is just a relentless enemy. It grinds down parts, it turns useful energy into wasted heat, and it costs industries billions. For decades, we've tried to fight it with chemical additives, but honestly, those have kind of hit their limit. Plus, they often come with a pretty heavy environmental price tag. So, yeah, we need a new hero. And that's where this hero comes in. Say hello to onion graphene, or as scientists like to call them, carbon nano-onions. So what is this stuff? Well, think about a single atom-thin sheet of carbon. You've probably heard of it. That's graphene. Now, just imagine dozens of those sheets wrapping around each other over and over to form a perfect, tiny sphere. That is onion graphene. It's a structure that's not just elegant, it's unbelievably powerful. And wow, this image just perfectly illustrates what we're talking about. This isn't a computer rendering, it's a real picture from a super powerful microscope. You can actually see those concentric layers, just like in an onion. And it's this beautiful, nested structure that is the source of all its superpowers. And check out the specs on these things, they're just incredible. We're talking about spheres that are only 30 to 60 nanometers wide. That is tiny. Each one is made of 40 to 60 nested layers of graphene, and they're more than 99.5% pure. This isn't some random blob of carbon, it's a precisely engineered material. Okay, so why does any of this matter? Well, because when you get down to the nanoscale, structure is everything. So let's take a look at how this incredible structure is even made. What's really wild is that these perfect spheres aren't carved or molded into shape. They're grown. Scientists use this process called pyrolysis, which is basically zapping hydrocarbon gas with super high temperatures. And in that crazy environment, the carbon atoms literally build themselves. They self-assemble into these flawless, multi-layered spheres. Amazing. Now, this part is really key to understanding why this is such a breakthrough. See, most of us think of graphene as a flat sheet, right? But flat sheets have problems. They can tear, they can crumple up, they can stack inefficiently. Onion graphene, because it's a closed-off 3D sphere, just avoids all of that. It's a totally different and way more robust way to use carbon. And that unique shape? Well, it unlocks a whole suite of incredible abilities. I mean, we are talking about genuine material superpowers here. The biggest superpower of them all is how it completely changes the game with friction. The secret is in the shape. Think about it. Spheres roll, they don't slide. Instead of surfaces grinding against each other, they can now just roll on top of these microscopic spheres. There's a great name for this. Scientists call it the Nano-Bearing effect. And it's just elegantly simple. These little carbon nano-onions act like the world's tiniest ball bearings. They take that destructive sliding friction and turn it into super low rolling friction. That right there is the core of its genius. But wait a second. For a tiny ball bearing to actually work, it's got to be incredibly tough, right? I mean, it can't just get crushed the second you put any pressure on it. So that leads to the big question. Just how strong are these nano-onions? Get ready for this. 5 gigapascals. That is the insane amount of pressure these tiny spheres can handle before they even think about breaking. It's a massive number, but let's be real. What does that actually mean? Okay, let this one sink in. That's 50 times the pressure at the bottom of the Mariana Trench, the deepest point on the entire planet. A flat sheet of graphene would be toast. It would just be obliterated. But these perfect spheres, they just shrug it off. It's all about the geometry. Their shape makes them unbelievably strong. And the list of superpowers just keeps going. They can handle crazy high temperatures, up to 700 Celsius. They conduct electricity really well. They can even absorb UV radiation to protect other materials. And on top of all that, they're safe, non-toxic, and biocompatible. This is definitely not a one-trick pony. It's a whole new platform for materials science. And the best part? This isn't just something stuck in a lab. No, this microscopic hero is already out in the real world, solving real problems right now.
You can already find them being used as additives to boost diesel engine performance, to protect those huge gearboxes in factories, and to make drilling and metal cutting fluids way more effective. It's even being used in high-performance lubes for motorcycles and bicycles. Basically, it's making our entire mechanical world more efficient, piece by piece.
So, onion graphene has handed us this powerful new weapon in the fight against the ancient problem of friction. And it really makes you wonder, doesn't it? If we can solve this by engineering materials atom by atom, what other huge challenges, what other forever problems are we on the verge of solving next?